Okay, this is the third learning outcome. We will actually focus on binomial distribution. So now we will look into what are the key conditions of a binomial distribution. So for a binomial distribution, as the word says by, so the number of possible outcomes are always two. So you have to decide which is the success and which is the failure. Okay, and the number of trials, each trial should be identical. So example, if you're tossing a coin in the first trial, the second trial should also be tossing a coin. Okay, and the trials are independent of each other, meaning when you toss the first coin, it doesn't affect the toss of the second coin. Okay, and the probability of success is actually equals to P, which means it is constant or same for each trial. So for example, probability of turning a head should be half, and it's half throughout the event. Okay, if these conditions are met, then X has a binomial distribution with parameters n and p. So n are simply number of trials, and p is actually probability of success. Okay, so this is how you write your binomial distribution. X is binomially distributed with parameters n and p. So n, again I repeat, a number of trials, and p is the probability of success. Okay, this is the binomial probability formula. The purpose of this formula is to actually calculate the probability of a certain number of trials. Okay. So the formula is written in such a way: Px equals to the smaller x. The smaller x here simply means it has to be a whole number like 0, 1, 2, 3, and so on. Okay. And x is the number of successes you obtain out of n number of trials. And P refers to probability, and Q here refers to failure. NCX or NCR, you have learned NCR when we learn binomial theorem in semester 2 for expansion purpose, for binomial expansions. So it's a similar button on your calculator which you can use to calculate NCX, which is also NCR. Okay, so I hope you recall back how to actually calculate NCX. Okay, and just want to highlight again, n is number of trials, p is probability of success, q is probability of failure. So x has to be the number of successes, which is always a whole number, yeah. And the sum of p and q, because p is the success and q is the failure, so every event, so for example, when you toss a coin, the probability of success, say, is you set as head, getting a head is a success, then the probability of getting the failure will be q. So probability of getting of head is half, and probability of getting a tail, which is q, is also half. So the sum of half plus half is actually 1. So please pay attention that the sum of p and q has to be always 1. For example, the 4 possible outcomes that could occur if you flipped a coin twice is listed in the table below. So there are only 4 possible outcomes when you toss 2 coins. The possible outcomes are getting a head in the first flip and second flip, getting a tails in both flips, getting a tail in the first flip and head in the second, and vice versa, in heads in the first flip and tails in the second flip. So the probability of a head on first flip and a head on second flip is the product of, because it's n, is the product of half multiplied by half, which is factor. Okay, so please pay attention on this. Next, the 4 possible outcomes can be classified in terms of the number of heads that come up. So the number here could be 0, 1, and 2. So we are setting probability of getting a head as a success. Okay, so we can summarize it in this second table. So the probability of getting number of heads, either you get no heads, means both coins gives you tail. So number of heads is 0. Either you get number of hits in one of them, or you get hits for both. So the number of hits possible are 0, 1 and 2. So the probability of getting no hits is quarter. Probability of getting one hit will be half, obviously, and probability of getting two hits will be half multiplied by half, which is quarter. Okay, this is an example of binomial distribution simply because it has independent and identical trials, two possible outcomes for each trial, head or tail, and the probability of success is the same for each trial. That means if you toss a coin, there's a probability of half and half to get a head and also a tail. Okay, so this is how we're going to apply this formula, binomial formula. Okay, so for example, x is binomially distributed, n is 10 and p is 0.4. So if you're required to get the successes equals to 7, okay, so you plug it into the formula. So NCX, so it's 10 and x is 7 over here, and then p to the power of x, so 0.4 to the power of 7. This is 1 minus 0.4, so it's 0.6 to the power of 10 minus 7, which is 3. Okay, use your calculator and you will arrive to this answer. Second example, if y is binomially distributed, n is 8 and p is 0.15. So if you're required to find probability of y less than 3, so in this case, if it's less than 3, so your possible values should be, don't forget 0, yeah, students normally forget 0, please pay attention. So y should be 0, 1 and 2 because it's less than 3. So it should be 0, 1 and 2. You need to just add the 3 probabilities. So using the binomial formula, for the first one, x is 0, n is 8. So n is 8 for all 3, as you can see here. And the difference here is only the x. So the x is 0 for the first one, 1 for the second one, and 2 for the third one. So I'm calculating each of these individually. 2 is this one, right? So substitute it into the formula, and you will actually arrive to this answer, 0.8948. Third example, say W is binomially distributed, N is 50, and P is 0.12, and you're required to determine probability of success W being larger than 2. So if it's larger than 2, over here you have N as 50. You can always calculate 3, 4, 5 until 50. It will take forever. Okay. However, you can modify or shorten the time for your calculation by modifying the calculation here. You see, you need W more than 2. So more than 2 here, you can't be calculating till 50. So what you need to do is, total probability is 1. Take away probability of less than 2. So you will get whatever is larger than 2. That means you get probability of 3 and so on. Okay. So for example, 1, take away 0, 1 and 2, because 0, 1 and 2 represents probability of W being less than 2 or equal to 2. Okay, so here you simply apply the binomial distribution formula. So pay attention, your n is 50, your x is actually 0 for the first one, 1 for the second one, and 2 for the third one. 0.12 is the p given, and this is 1 minus 0.12, and this is n minus x. Okay, so it's 50 minus 0, 50 minus 1, 50 minus 2. Right, substitute it accordingly. With the help of your calculator, you can actually arrive to the final answer. Okay, so this is how you actually apply the binomial formula for calculation purpose. The fourth learning outcome focuses on how to determine mean, variance, and standard deviation for a binomial distribution. So mean, also known as expected value, is NP. variance is NPQ, and standard deviation is obviously set of variance. Okay, so next we will look at how we're going to apply these formulas if you are given a real scenario. So for example, if you are required to find the mean and X fulfills all the binomial distribution criteria, and provided you know the value of n and p, then the mean can be calculated as NP, the mean or the expected value. Yeah. Some textbooks actually use expectation as well. So these are just some of the terminologies used widely for statistics. So for example, the chance of getting a red sweet from a box of 40 colored sweets is 1/10. So n is 40. The number of trials are 40. Okay, and the probability is 1 out of 10. So we can model this scenario as this. Yeah, X is binomially distributed, 40 and 1/10. Okay, so in this case, you are expected to calculate how many red sweets you expect to get in each box. So very simple. Expect here, expect is expectation, expectation is mean, so the formula will be expectation is NP, so N is 40 and your P is 1/10, so your mean resultant here or the expected value here is 4. So when it comes to variance, again, if you fulfill the criteria of binomial distribution, then you can apply this formula for variance. Variance is simply sigma squared. Variance is NPQ. Q is 1 minus P. Alright, and just make sure that the sum of P and Q is always 1, yeah? So for example, a 5-sided spinner numbered between 1 to 5 on each sector is 12 20 times. So 20 trials. So X is binomially distributed, N is 20, and the number of trials are 20, and the probability of getting 3 would be 1 out of 5 because there are only 5 sectors. So probability of getting a 3 each time has to be only 1 out of 5. Okay, so you got your N is 20, your P is 1 out of 5, right? So we are setting getting a 3 as a success here. That's where you get your P is 1 out of 5. Your expectation, which is what do you expect? How many times would you expect the 3 to appear, will be NP. So N multiplied by P is 4 here, right? And then the second part here requires you to get variance. Variance is simply NPQ. So N is 20, P is 1 out of 5, and your Q is 1 minus 1 out of 5, which is 4 out of 5. You'll arrive to your variance value, which is 3.5.